In Algebra 2 today, we're going to be talking about multiplying polynomials. And you've been multiplying polynomials since the days of early Algebra 1. If you recall, multiplying binomials, such as a minus b times a plus b. Each of these is called a binomial that has two terms. Well, to multiply any binomials, we use the acronym called FOIL, right? Multiplying the first times the first. So a times a, we get a squared. Multiply the outsides, a times b, we have positive ab. The insides, negative b times a is negative ab. And then the last terms, negative b times b is negative b squared. And then if there are like terms, we collect them. In this case, because we multiplied two binomials that are really the same, just with a different sign in between them, those kinds of binomials are called conjugates. When we multiply conjugates, the result, the product of the outsides and the insides, will always cancel out. So we'll end up with, well, ab and minus ab is 0, so we end up with a squared minus b squared, right? Another way you might have seen this is set up in a square, right? Like to multiply a minus b times a plus b, you have an a and a negative b, and then an a and a positive b. And we multiply each pair of terms and put the product in each box. A times a is a squared, a times b is ab, negative b times a is negative ab, negative b times b is negative b squared, and then we collect any like terms. But we still write our answer like this. So whether you organize it in some kind of a box or you just use the FOIL method like I use, it doesn't matter. You still write your answer in this way. This is old stuff, right? So you also have written out problems like a plus b squared. Don't forget this, but when you have a binomial, a plus b squared, you have addition or subtraction between them, and you're squaring this. This is not equal to a squared plus b squared. Am I going to be off the board now? I don't know. This is not a squared plus b squared, right? You have to treat this like a foiling problem. It's very similar to the first one, right? A plus b squared equals, the next line would say, a plus b times a plus b. And it's a problem like this. But a lot of things don't cancel out here. Here we multiplied conjugates with the different signs, and the middle terms cancel. Here that won't happen. A times a, let's just do a little foiling, is a squared. A times b is ab. And then a times b again is ab again. And then b times b is b squared. So we have a squared plus 1ab plus 1ab, so plus 2ab. Right? When we collect like terms by adding, we don't change the variable. We just change the coefficient. Plus b squared. That's the answer. Okay, keep in mind that we went from a plus b squared to this. That's the answer. It's not just a squared plus b squared, although that is part of the answer. You still have a 2ab term. Now the nice thing about this is that if you remember that formula, you can use that to do any problem such as like x plus 3 squared. If you remember that the way it works is always, well, the first number is squared, so the first term, I should say, first term squared will be first, right, a squared, and the middle term is 2 times ab. Well, what is ab? ab is the product of the first and the last term, the first and the second term. So ab here is x3, 3x, right? So 3x times 2 is 6x. All right, so again, ab is just the x times the 3, 3x, but then there's a 2. So 3x times 2 is 6x plus b squared. 3 squared is 9. So if you remember this sort of formula on how to handle a binomial squared, well, you can easily figure out any binomial squared. All right, this is all old stuff, but I wanted to review it. All right, now the next thing I want to get to is multiplying some higher degree polynomials. So what about multiplying a binomial by a trinomial? Well, I don't know if I'll get into that, but organizing that situation like this would be a good idea. Because of time, I want to just get into multiplying or finding a formula for a plus b to the third. Okay? That's a strange problem. And you know what? when we do this problem, we will inherently be multiplying a binomial by a trinomial. So it'll kill two birds with one stone. Even though this is a more complicated problem than something like, x plus 2 times x squared minus 3x plus 1. You should probably know how to do that. You should know how to do that. All right, but we're going to handle a problem like this when we just handle this problem anyway. All right? If we have time, I'll do that one later. All right? So a plus b to the second was not a squared plus b squared. Well, in a similar way, this is not a to the third plus b to the third. Okay? That is not how to handle a sum to a power. You have addition or subtraction to that power? Not the case. Now, if you just had a product like ab to the third, yes, that is a to the third b to the third, or a divided by b to a power is a to that power divided by b to that power. That is true. But when you have addition or subtraction, it's not the case. Okay? So that's all well and good, but this is not true. Keep that in mind. We have to write this out 3 times. A plus b to the third is a plus b times a plus b times a plus b. Now, how do we multiply 3 things in general? You get the point. How do we multiply 3 things in general? Do we distribute this to both of these? No, you wouldn't. If you're multiplying 2 things, say 2 times 3 times 4, 3 numbers, 3 terms, whatever. We don't multiply 2 times 3 and then 2 times 4. No, we just multiply any 2 of these, doesn't matter the order, and then the product by the third number. So like 2 times 3, for instance, one way to do this is 6, and then the product 6 by the 4, and we get 24, the answer. Or 2 times 4, 8. 8 times 3 is 24. Or 3 times 4, 12. 12 times 2 is 24. So keep that in mind when we do this. We multiply any 2 of these. They're all the same, so it's not going to make a difference. But multiply any 2 of them, and then see what you get. And then that result, you multiply by the third one. Well, if you think about a plus b times a plus b as a plus b squared, right? So we'll have this a plus b times, this is really a plus b squared, right? A plus b is a plus b squared. So we just did that, and that's right here. A squared plus 2ab plus b squared, right? So because we just did that, that's what that trinomial is. A plus b times this stuff. And now, this is what I was saying. It's a problem like this. We're multiplying a binomial by a trinomial. So again, it's sort of like foiling, but there's 6 multiplication problems. There's 6 products to find before we collect like terms, instead of there just being 4, as there were here. 1, 2, 3, 4 multiplication problems. Now there are 6. Each of these guys gets multiplied through by every one of those 3. All right? So again, you might want to make some kind of a box, or you could just show the lines like I did here. Let's do this box. Again, I don't do this, but I want to show it to you guys because some of you have learned this in the past. Whoops. I have to leave room for, let's do this here and there. Okay. So we have an a and a positive b, and then an a squared, 2ab, and b squared. Right? Those are all positives. They're all positives. So now we multiply every combination and put them in the boxes. A times a to the second is a to the third, right? A to the third. A times 2ab is 2a squared b, is how we would write that. A times b squared is just ab squared. A squared b is just a squared b. B times 2ab is 2ab squared. And then b times b squared is b to the third. Are there any like terms? Yes, there are a couple, right? The a squared b here and the a squared b here. I'll make a little check mark there and there. Those are like terms. 1 a squared b plus 2 a squared b is 3a squared b. So we have the a to the third to start. Then we have our 3a squared b. That's a b. And then we have 2ab squared and 1ab squared. Do a little double check there. These are like terms. So we have 3 a, we have 2 and then 1 is 3ab squared. So plus 3ab squared plus b to the third. Okay, that is what a plus b to the third power is. That's how you would do it. That's the answer. Okay, it's not easy. This is algebra 2, so it's a longer process. Now, keep in mind, we can use this formula like we use this one. We used this one to do x plus 3 squared a minute ago. Let's do the same thing with x plus 3 to the third. Okay, x plus 3 to the third, write this down here. So our a is the x and our b is the 3 once again. So x is going to go here, so we have x cubed. So the answer, we can save ourselves some time if we just remember this formula. X to the third plus, well, the a is the x, we have 3x squared times, well, b is 3, right? So we have 3 times the 3, we have 9x squared, right? B is 3. The b in this formula is like our 3 over here. All right? Then we have plus 3a, which is x, so 3x, times b squared. 3 squared is 9. So 9 times 3 is 27, plus 27x, plus b to the third, b is 3. 3 to the third is plus 27. That's the answer. Is that off the screen? Let me see. No, it barely fits on there. Phenomenal. All right. Anyway, it's not that this is the kind of formula you would necessarily have to memorize. It might be more trouble than it's worth, but I wanted to show you that this is the general case. If we have a sum of 2 terms, in this case a and b, to the third power, this is the process. But this is what we've used the general case to get this. So no matter what the first and the second terms are, we could just plug them into this formula if we want, instead of going through the whole process on our own, all right? But this is what we get. Now, x to the third plus 27, right? 3 to the third is 27. So if you made the mistake of doing that and just writing x cubed plus 27 as your answer, which is wrong, that is part of the answer though. You're just forgetting quite a bit of it, all right? So you have to think of this like x plus 3, x plus 3, x plus 3. All right, and then again, handle 2 of them separately, and then multiply the binomial by the trinomial that remains. Okay? So again, I kind of wanted to show you the general case for cubing a binomial and also do a little bit of a review. All right? So this should help you do the remaining problems for your homework. Have a nice day.